Hey everyone, it's Mrs. Brimlow, and today we're going to learn how to solve systems of equations using a different method called substitution. So there's a copy of the notes linked in Canvas, or you can watch the video and get a copy when you're back in class. So we're going to skip the warm up and we're going to go straight into the notes, okay? So solving systems by substitution. This is a method of solving systems of equations by substituting one equation into another. And we've been working with substitution for a long time already, substituting ordered pairs into equations and functions. So we're using that similar concept here to solve. Now, it is going to be a lot of steps, so it's easy to get lost. This is only day one, so I don't expect you to leave experts, but really make sure you're paying attention, using the strategies, and writing all the steps down. So all the steps are written here in Word step by step, which I think is really good, but I actually just want to go through the process. I am going to jump around a little bit on these notes just because I want to do some different problems and make sure we get a mix of each. So we're actually going to start on the second page or the back of the notes, and we're going to start with number 5. Okay. So substitution means to replace. So we're going to be replacing one of our variables with either a number or expression. So we need to look for which equation is already solved for one of my variables. So starting with number 5, I have y equals -4, and then 3x minus 5y equals 23. So that means the first equation is already telling me what the value of y is. It's -4. So I'm going to use a highlighter and highlight what it's equal to. And then I'm going to highlight what it's going to replace or substitute in the next equation. That way we can solve for x. So I'm going to come over here. So I have 3x minus 5. Now this is saying to do 5 times y. So we're going to do 5 times -4 and then equals 23. So once again, we already know the value of y. It's -4. So I'm just substituting it into this next equation in order to solve for my second variable, x. So now I'm going to solve. So I'm going to bring down this 3x, -5. Make sure you take the sign in front of each number. Times -4 is 20, equals 23. And now I just have a two-step. So minus 20, 3x equals 3, divided by 3, and x equals 1. So as an ordered pair, we have x is 1, and we know y is -4. So that means if I was to graph these two equations on a coordinate plane, I would see that they intersect at this solution. Okay. All right, we're going to take a look at the one above it, number 2. Once again, we're going to start by looking to see which equation is already solved for a variable. And you're going to notice it's the first one. Now this time it's equal to an expression. So it's not just one simple solution. So this is going to involve a few more steps, but we're still using that same process. So they're telling us the value of y is -4x minus 23, that whole expression. So same thing, we're going to replace y in the second equation with that expression. The reason for that is what we're going to see. We can't solve for x and y at the same time. We can only do one at a time. So when I go to replace it, so not -4x, I keep that -3. Now this is saying to do -3 times y. So that means I'm going to do -3 times that expression, -4x minus 23, close the parentheses, and that equals 13. When I go to solve this equation, you're going to notice I'm only working with x now. I can solve this equation, meaning I can figure out what at least one of my variables is. Then we'll talk about how we find our next one. So order of operations tells me distributive property first. So I'm just going to bring this down. so plus 12x, and then negative 3 times negative 23 is 69 equals 13. Now, properties tell me that I can combine like terms. So negative 4x and 12x is 8x plus 69 equals 13. So now I'm just down to a two-step. So this part should be all reviewed. So I'm going to kind of fly through this. Apologize, there's not a lot of space. So 13 minus 69 is negative 56 divided by 8. X equals negative 7. So we have one part of our ordered pair where they're going to cross, but how are we going to figure out y? Well, when I come back to my system, they tell me that y is equal to negative 4 times x minus 23. Well, I know what x is, so all I need to do is substitute it in and see what y is. So y equals negative 4 times negative 7, and then subtract 23 from that. So y equals negative 4 times negative 7 is 28 minus 23. So y equals 5. So as an ordered pair, the solution is negative 7, 5. That's for the other one. Okay. A lot of steps involved. It's very easy to make a mistake or get lost, which is why it's really important you take your time and show all of your work. That way, if you do make a mistake, you can go back and see where was that mistake, okay? And you can use a calculator on this. I don't expect you to do all of this in your brain, especially with some of these bigger numbers, okay? So one more that I'd like to do with you is back on the front for today. All right, so we're going to take a look at the very first problem. So same thing, we're going to see which variable is solved for y. Well, they're saying that y equals x minus 9, and they're also saying y equals 4x minus 24. So if this equals y and this equals y, what does it mean about these two statements right here? Well, if they're both equal to the same variable, that must mean that they are equivalent. So what that means is x minus 9 equals 4x minus 24. So once again, both of these expressions are equal to the same variable. So if they both equal the same variable, then they're both equal to each other. Okay. So now I'm looking at solving equations with variables on both sides, which is something we did work on this year. There are a lot of ways to start solving this, but I'm going to go through this how I would recommend. So first step is to get variables on the same side. Now, I can't just add them together because they're not on the same side. So just like with our constants, I have to move them by either adding or subtracting one of them. And I always look for the one with the smallest coefficient. So I have x and 4x, so I'm going to subtract x from each side. So this leaves me with negative 9 equals 3x minus 24. So now I'm just down to a two-step, okay? So once again, we subtracted x from both sides because what we do to one side, we do to the other. We want to keep it balanced, but I can't have variables on both sides or I can't solve this. So now I'm going to finish solving. So this is 15 equals 3x divided by 3 and x equals 5, okay? Now, because both of these equations are y equals, it doesn't really matter which one you use to solve for y. Either way, you're going to get the equation. I like to look with the one that has either the least amount of steps or smaller numbers. So that would be the first equation, but once again, you can use either of them. So y equals x minus 9, so y equals 5 minus 9, which is negative 4. So my final answer would be 5 comma negative 4. That's where they would intersect, okay? So we're going to stop here for today. You're going to finish the problems on these notes, and then there is another worksheet that you can do for more practice. If you have any questions, let me know, and I will chat with you soon.